Another strategy we're going to need for finding the real zeros of a polynomial function in section 5.6 is something called Descartes' rule of signs. So he was a famous mathematician who came up with this strategy or theorem. Let f denote a polynomial function written in standard form. What do we mean by that? Starting with the highest power on the variable, working down to the lowest power in a constant if there is one. The number of positive real zeros. So remember, we're looking for all the real zeros. It might be helpful to know how many positives and negatives there are. So we can get the number of positive real zeros of f. We can find out how many to expect, and it's either equal to the number of variations of the sign of the non-zero coefficients of f of x. Okay, so what does that mean? The non-zero coefficients means, so if as long as, if you didn't have an x squared here, it would have a zero coefficient, so we wouldn't worry about that. So we're looking for variations of sign, the number of. We're counting how many times the sign changes in standard form for all the terms that don't have a zero coefficient. Or else it equals that number less an even integer. So let's see how that works here in just a minute in this example. The way we'll do the negative, we'll count our negatives, will be the number of variations of sign, same thing, of the non-zero coefficients, but now of f of negative x, or else that number less an even integer. So we'll see how that works here. In this example, we're just supposed to discuss the real zeros here. So I'm going to find the number of positive real zeros, put something there, and the number of negative real zeros. All right, so for positive, we're supposed to count the variations of sign in f of x, starting at the beginning. Positive to positive, there's no variation there, so I haven't counted anything yet. Positive to negative, there's 1. I just counted 1. So it varied to here. Negative to negative, that's no variation. Okay, so the number of positive real zeros is the number of variations of sign. There was just 1. Or that number less, minus, an even integer. Well, I can't subtract, when I try to subtract the smallest even integer from 1, which would be 2, I get a negative number. And that makes no sense to say you'll get a negative count of something. So 1 is it. I can state for sure that this polynomial function has 1 positive real zero. I know that because of this. There are no other options. Now it says to do the same, but for f of negative x. So let's find out what f of negative x is. Negative x cubed plus 2, negative x squared minus 5 times negative x minus 6. What I'm trying to do is get all the correct signs here. So, move that down a little bit. So, the first term, a negative to the third power is going to be a negative. So we have negative x cubed. Negative squared is positive, so that one doesn't change sign. It was plus 2x squared, and it's still plus 2x squared. But when I put a negative in here, that makes a double negative, so I have positive 5x and minus 6. So what you notice is all the odd powers of x will change sign. That one became negative, that one became negative. The even powers don't change. Now we're doing the same thing we did in f of x, but now for f of negative x, counting the sign variations, the sign changes. Negative to positive, there's 1. I've counted 1. Positive to positive, no change. Positive to negative, there's another one. So my total is 2. But it said, or else that number minus an even integer. Okay, so the only even integer I could subtract from 2 would be 2. I can't subtract 4, okay, but I can subtract 2, and I can do that and say it's either 2 or 0. 2 minus 2. Why an even integer? Well, the reason for that is if we did have some non-real zeros for the polynomial, they come in pairs. They come in conjugate pairs, remember? So they don't come individually, they come in pairs. So I know I've got one real positive one, but I could have two negatives, or if those two are non-reals, then I won't have any negatives. So my options are one positive real and two negative reals, or one positive real and no negative reals, because I have two non-reals. And the total, the maximum number of real zeros I can have is what? 3, because this says a polynomial function cannot have more real zeros than its degree. So I know the most I can have is 3. I could have 1 plus 2, or I might just have one real zero. But the most is 3.